Hello everyone. So today I will discuss the acronym L from the solid. Okay, so L stands for Liskov Substitute Principle. Okay. First we will go to the definition and then explain you a bit about it, just about it. Okay, so definition I've written in front of you, so I'll just read it out, then I'll give you the explanation. Okay, so definition is the principle defines that object of a superclass shall be replaceable with object of its subclasses without breaking the application that requires the object of your subclasses to behave in the same way as the object of your superclass. Okay, so you can see the terminology is coming between the superclass and subclass. Okay, so I'll make it much more better and clear. So let's assume you have a parent class. Okay, and in parent class you might have some functions. Okay, and you have created a child class of it, and the same function you're overriding it, so that function definition should be same and also the return type should be same. This is what the scope substitute principle is basically about. Okay, we have to maintain the return types and the function definition. Otherwise, let's assume if you are not maintaining the return type and you are doing let me, you have overridden it and then you are calling that function, definitely you will be getting different output from parent and different output from the child function that you have written it. So that will not be worked as properly. Okay, so this is why it has to be proper. Now we will dive into the code a bit because we should know the examples if the interviewer asks for it and we should be knowing it. Okay, I have created the two examples for you, a good example and a bad example. Okay, under the L principle package. Okay, and even in that package I've created two package, one is a good and one is a bad. Okay, so firstly we will take up the good example. Okay, now you can see I've created a class animal. Okay, and I've created a function called make sound. Okay, this is the class you might be visible to you. Okay, then I'll show you the two classes which I have extended it. That's a dog which is extending the animal. Okay, and in the make sound function also I have overridden it, so I have written dog will bark. Okay, as simple as that. Okay, now I have taken another example of cat. Okay, here also cat is extending it and then it's providing its own functionality that cat will meow. Okay, now you can see this is my animal parent class and I have two subclasses or child class you can call. Okay, so I've overridden the functions and their format is also proper. This is what we are expecting from the now from the solid principles from the L basically. Okay, now to make it code run and all, I have created one animal feature also which will be actually calling the whichever animal sound we have to call. So it's taking a reference of an animal and it's calling the make sound function on that. Okay, so this is actually calling the parent class animal. Now whichever object comes up, it will go to dog or cat. Okay, I'll show you the client also. So I can see the animal feature object I have created and also the dog and a cat object I have created, but reference is of my animal. Okay, so that I can send it to the common function which I've created for features, animal features. Okay, so dog and cat. If it is a dog, it will go to the dog make sound. If it is a cat, it will go to the cat make sound. Okay, so this looks straightforward, right? So this is what we are expecting also. Now I'll show you also the bad examples. Okay, so that we should be knowing if interviewer asks us like how it will be breaking it up. Okay, so for this you can see I've created one bird class. Okay, so this bird class is like, again I've created a common, you can say a parent normal class which I was thinking of. Okay, so bird fly is one function in that. Okay, and I've written a s out saying that bird can fly. Okay, now I will be having again two classes which are extending it. So you can see a parrot class which is extending the bird class. Okay, in this I've written parrot can fly straight as forward. Okay, and there's another class sparrow. Okay, sparrow is extending bird. In this you can see I'm not written s out. In place of that I'm throwing an exception. Okay, now see bird, now again the same similar thing is like I have a class parent class and the two child classes and I've overridden the function. That function is word fly. In the bird fly, in the parrot you can see I am returning the same type like void, so my return type is also void, nothing I'm returning it. Okay, but in sparrow you can see I'm throwing an exception. So this is where I'm breaking the Liskov substitute principle. Okay, this is what we should not do it. We have to maintain the structure that we have from the parent class. Okay, so this is the wrong. Okay, this should not be done. I'll just go and further explain the code which I've just for running purpose what I did. So it's a bird flying feature which I have it. Okay, and then the bird fly function will be called and this class object I'll be creating in my client one. So yeah, so you can see bird feature I've created over here. I've created parrot object and my again reference or my base class will be bird. Okay, and then I'm sending the parrot, sending the parrot over here and also the sparrow. Okay, so for you I can just run it once and then maybe show it to you. Okay, yeah, so you can see First one it ran and parrot can fly came, and then the next one is like I got an exception. Okay, so this is what even I was expecting because I've written in a sparrow through an exception. Okay, sparrow cannot fly, so this is where it is. Okay, so yeah, this is what I was about to explain to you. I hope you guys would have understood. If you still have some questions, put it in the comments. I'll go and explain over there also. And see you in the next video. Thank you. Bye bye.